start with trigonometry. So when we talk about the subject of trigonometry, a lot of it, well, in grade 10 at the beginning of grade 11, it comes back to these basic ideas where we talk about a right angle triangle. Okay, so a right angle triangle, and here I have my right angle triangle over here. And then we have what's called a reference angle. So my reference angle is over here. And then we give the sides in a right angle triangle names. So we call this side over here opposite the angle the opposite. We have the hypotenuse, which is opposite the right angle. And then we have the adjacent, which is the other side. And so in trigonometry, we talk about trig ratios, and the ratio for the sine or the value of the sine of theta is just the length of the opposite. Let me use a yellow. The length of the opposite divided by the length of the hypotenuse. And then that's one trig ratio called sine. And then there's two others called cos and tan, and they also just involve the ratio of lengths of sides of a triangle. Now, that is something which we generally cover in grade 10, but sometimes students miss it for whatever reason. And we often use the abbreviation O for opposite, and then we use H for hypotenuse, and then we use the abbreviation A for adjacent. And so in order to remember what trig ratios go with what, we use I think it's called an acronym called SOHCAHTOA, where you can see that sine is over H, cos is A over H, and tan is over A, where each of the O's and the H's are lengths of sides in a right angle triangle. So that's the most basic ideas that we need to think about as we begin today. And the other thing is that trig involves a relationship between an angle, in this case, it will be called the reference angle over here, and a ratio of lengths of sides. Give me a thumbs up if that looks familiar to you. Give me a thumbs down if that looks very unfamiliar to you. Just want to have a quick little overview that you guys have seen the basic ideas that will be underneath this lesson today. So vote thumbs up if you feel like, yeah, I've seen that before. That rings a bell. And so on. Okay, now, in grade 10, we predominantly just work with a triangle where the reference angle is acute, where theta is less than 90. However, later on in the series, we are going to extend it to the Cartesian plane. And at that stage, something changes a little bit. Now, take a moment to look at this block of information, and I would love for someone to come online and tell me what's a little bit different about the block on the right-hand side. It's got similar information to the stuff on the left, but there's some subtle differences. And I was wondering if somebody would be willing to come online and explain to us what is going on in the red block, the one that I've outlined. And if you just unmute yourself, we'll let you make a comment. So let's go to Sia.
Hi,
Sia.
sir.
Hey.
So I think it's because now it's on a Cartesian plane. That's why it's different.
Yep, that's exactly right. So instead of having the triangle be by itself, the triangle is sitting in the Cartesian plane. Can you tell us about the X and the Y and the R? What is that? How does that come into it?
Sir, you see now, because it's on a Cartesian plane, if it's on the first quadrant, I think they are all positive, sir.
Yes, love it.
Yeah, it changes if the quadrants, if the triangle also goes into a different quadrant, then some of the numbers will change and become negative.
Perfect. Thank you so much, Sia. That was super helpful. So we're not going to talk about this too much more today, but one of the things, the big differences between grade 10 and grade 11 is that in grade 10, the triangle can't go into different quadrants, and so it just stays in one quadrant. However, if you can imagine, if we move this triangle to different quadrants, instead of the x just being positive or the y just being positive, it could be different values, which we'll come back to. The main other thing is that instead of using O and A and H, you also notice that we're using X, Y, and R. And X represents the length of a side of the triangle, Y represents a length, and R represents a length. And they're just being defined in terms of instead of being by themselves, you're on a Cartesian plane. And so we're using Cartesian plane notation. You don't have to understand this deeply, but just give me a thumbs up if you see the bit of connection between the thing on the left and the thing on the right. Like you can see how they're related to each other. Okay, so we're going to come back to the X, Y, and R definition for trig ratios later on. But at the moment, what it really is that the trig ratios and triangle from grade 10 is going to be put on a Cartesian plane in grade 11, which is going to allow us some extra options, which we're going to come back to later. Okay, so let's do a little bit of practice. So here is a multiple choice question, testing your knowledge of the basic ideas of trig. What is the value of the sine of theta if I give you a triangle like that? And I want you to vote by putting your vote in the chat. I see a couple of different options. That's fantastic. Keep them coming. What I like to do sometimes is label the different sides. So that would be an O, that would be an H, and that would be an A. So we need to know what the sine of theta is. And so since the sine is O over H, I was thinking O is 3 and H is 5. Now, there is no 3 over 5 here, but 3 over 5 is the same as 6 over 10, or 0.6. And so the correct answer should be 0.6. All right, so that was done quite nicely. So this is just testing, like I was saying, if you've got a triangle and it's a right angle triangle, you can work out the trig ratios of any of these over here. In fact, here's my little extra question. I'm making one up specially for you. What is the cos of theta going to be equal to? So originally I asked you what is the sine of theta, but what about the cos of theta taken from this triangle? Which option is that going to be? Okay, so you seem to have quickly remembered that cos is A over H, which is 4 over 5, which is the same as 8 over 10, or 0.8. Looks good to me. Love it, love it, love it, love it. Okay, I'm going to move on. What about this one? What is the value of the tan of theta? Naledi, let's go to your question. What's your question, Naledi? Don't know if your hand is up or if it's okay. So over A should be 3 over 4, which is 0.75. Bianca, let's go to you.
Hi,
Hi,
sir.
Bianca. How can I help?
Right, when solving trig, right, and when we put it into a calculator, we would type like 10 and then like put the values in, right?
Yeah, so okay, so in this question, we're still doing the basics. We're going to get in the next set of MCQ questions. I'll come to the calculator. I know what you're talking about, but for the moment, we're just literally saying what is the ratio of the two sides, which is 3 divided by 4.
Oh, okay, because that's where I was
Okay.
getting confused.
Yeah. No, so this is the warm-up. I know what you're thinking about. You're thinking about a question like this. Let me bring it up. So, now I know what that's easy enough. That's easy enough. Let's say, that's also easy enough. Let's find one like, yeah, okay, let's find this one. Actually, let's do this one. So we'll get to harder ones now. I just want to make sure we have a good understanding. What is the value of the tan of 60? You can use your calculators here. I'm not going to prohibit you at this stage. But what is the value of the tan of 60? So if that's the O and this is the H and that is the A, it feels to me like SOHCAHTOA should be O over A. So root 3 over 2, which is going to be, I think I disagree with, so root 360, that's O, that's A. Let me get my calculator just to check, but I see some answers that are different. Who would like to have, aha. Okay, let's slow down for a second. So the first thing is, if I talk about the tan of 60, can you see how that involves this angle up here? And so when I ask you what is the opposite is opposite the 60 degrees that's involved. Now, the H is always opposite the hypotenuse, and then we label this A. Now, we want the tan of 60, which means we need O over A. Now, O is this root 3 over here. And then A is going to be this one. Oh, I see what I've done wrong. It's going to be root 3 over 1, which is D. Thank you. I could see the hands go up. I saw Annie's hand go up, and I knew. So the correct answer is going to be D. Okay. Are there any questions or comments about that? I don't know if I confused anyone. And I see our label also spotted it. Don't worry. It caught everyone a little bit. But quick little thumbs up if you feel okay with this. Thumbs down if you feel like unsure. So where did we get the 1 from? The 1 is over here. And that's the A. Okay, is that a question, Juliet? Let's unmute Juliet. Hi, Juliet. I don't know, maybe your hand, can you hear me? Or maybe there was just like a hands up that Juliet was giving us. Okay, let's try one more. Let's try and do this one, and then we're going to move on, because I think you've got the basic ideas of the trig ratios. What is the value of the sine of theta plus the cos of theta in this particular triangle? And I really want a student in maybe a minute or two to come on and explain to me what they're doing. That would be awesome. what do you think is important when you're trying to figure out what to do in this question? What do you think is important to keep in mind? If anybody's willing to share their thinking, because it feels to me like I'm looking in different places each time, and I'm wondering how you guys keep yourself organized. I see lots of answers coming through. Would anybody willing to share how they got there, or what thinking they used? It's not so much about the right answer at this stage. It's just about how you figured out what was what. If you are willing to share, just pop your hand up, and then we can have a quick little look at how you did it. Cynthia, let's go to you. What did you do, Cynthia? How did you approach this question? Let's see. Can you hear me, Cynthia?
Yes, sir, I can hear you. Can you hear me?
Loud and clear. What did you do?
Afternoon, sir. Afternoon.
Hey. Afternoon to you too, Cynthia.
We know that sine is equals to opposite over hypotenuse. So our opposite in this case is 7, and our hypotenuse side is 25. And we know that cos is equals to adjacent over hypotenuse. So our hypotenuse side is 24, and our adjacent is 24, and our hypotenuse is 25. So you add that together, and it gives you 1,24. So the correct answer is C.
Awesome. Thank you so much. I couldn't have done it better myself. And the thing I want to point out is how Cynthia really has a good understanding of where the A is and where the O is. And the fact that the angle was hanging out here on the top didn't really interest her. It wasn't confusing because she knew that the opposite was opposite that angle, which was great. Okay, cool. Let us move on now to a different type of question. So the point with this type of question is going to be finding unknown sides in right angle triangles. So we're going to use these trig ratios to find unknown sides. So in this question over here, the unknown side is going to be this A over here. And the side that we know for sure is this over here. The angle that we know is 31. I want to ask you, what trig ratio do you think I should use to try and find the length of the side A? So I'm not asking for an answer. I just want to know, what trig ratio do you think I should use to help me find what A is? Maybe someone can come online and explain to us how they knew what to do. Because I feel like I know how to do this with trig, but I'm just thinking, what trig ratio should I use? And why should I use that ratio and not another one? So some people have said sine, and some people have said cos, and some people have said Pythagoras. So there's a good amount of opinions out there. Let's go to Mussy. What would you do?
Hello, sir. Can you hear me?
I can hear you loud and clear.
So I think we should use cos because we were given the adjacent and the hypotenuse, and we are left to figure out the opposite. And another way we can find out the other one is by using Pythagoras, where we just say r squared equals h squared equals to x squared plus y squared, and then we find the missing one.
Okay. You did a lot there. Can I suggest we go with the very first thing you said? And the thing that I heard was that you labeled each of the sides so that you knew which one was which. Was that correct?
Yes.
Am I hearing you correct? And then you said, use the thing that you know and the thing that you want. So you said let me do this. You said use A and H, which I'm guessing is how you knew it was cos, right? Because cos has an A and an H. So then talk me through how you used the cos. What would you do then?
Well,
I suppose I
would say, But I haven't answered it yet. But I think I would just say cos of, but I'm lost now. Cos of 16. Cos of, no, no. I think I'm lost.
No problem. No problem. That's great. You set it up well. Thank you so much. Okay, so now I want to find what A is, and I'm going to take over. I'm going to say that the cos of 31 is equal to little a, which is actually the same as big A in this case, over 16. Give me a thumbs up if you feel like you understand how I wrote that the cos of 31 is equal to A over 16. Give me a thumbs down if you have no idea how I wrote that. Just want to see what the opinion of the class is here. So what I liked about what was said is whenever you have to find the length of an unknown, like an inner trig triangle, you'll notice that you're given one thing that you know, and then there's something that you want to know, and then there's an angle that you in the triangle which is not right angle. So all you needed to do was say, I know I'm using the cos ratio. So let me do that. I know I'm using the cos ratio. What angle am I given? I'm given the 31. And then I write out, well, what is cos? It's A over H. So it's A over here over the 16 down here. Now that is still a bit of a handful, so I acknowledge that that's tough. And then the last step is the 16 over here. I want to move it to the other side. So I get 16 times cos of 31 equals A. And so I want you to take your calculators now and type 16 times cos of 31, get a value, and then see which of the four options you would choose. Which of the options would you choose? So 16 times the cos of 31. And then tell me in the chat which of the four options you would choose. Oh, there's quite a few different things. Have I got my calculator nearby? Let me grab my thing quickly. So 16 times the cos of 31, I get 13.71. So I would go for option A as the correct answer. All right. So what I want to do now is I want you guys to have a go at a question like this using this idea. Vivian, what's your question?
Afternoon, sir.
Hi.
I'm just wondering, I don't know how you got cos, because
Okay.
is it because they give you the two values that are there that you use
Yes.
cos?
So what I did was at the very beginning when I had nothing, this is all I had. I know that opposite the right angle will always be H, and opposite the angle that I'm given is O. And then what's the only remaining thing that's left? It's A. Does that make a bit more sense? And since I have only these two bits of information, or what I want and what I know, what trig ratio involves A and H? And it's going to be cos.
Thank you, sir.
Cool. Let's do another one like this just to kind of practice. So in this question, I want you to try and find what is the length of side A. And I'm giving you this right angle triangle, and you need to think about the process that I just used and try and get the answer to that. And I'll give you some time, and then we can start giving each other hints in a moment. Maybe you can even put a hint in the chat if you feel like you know a lot about what's going on. What do you think a first step to do would be very helpful for everyone? I like it. Nkosi has said label. I think that is a great idea, Nkosi. I think I'm going to label them. So I know that's H. I know that this is going to be the opposite, which is a bit confusing because there's a label for A there. And then I know this one over here is going to be adjacent. So hypotenuse. So those are now what I want to deal with is I want to know what the length of this side is. And so I'm going to involve O, and I'm also given A. Now, what trig ratio involves O and A is the question. Sia, let's go to you.
So say, I realized that we were giving A and 21. So because A is opposite and 21 is adjacent, so I realized that we'll be using 10.
Perfect.
And then I said,
and the tan of what? Tan of what, do you think?
15
Tan of 15. Yep.
equals
And
to
then,
A over 21.
so good. And then?
And then I transposed the 21 to the other side, then it became 21, 10, 15.
Okay, and what did you get?
I got 5.6.
5.6. Okay, let me just quickly check. 21 times tan of 15. And I get 5.62, which rounded off. So I agree the correct answer is B. That's it. Lovely. Okay, before we have our break, let's do a quick little vote. Thumbs up if you're feeling okay so far. Thumbs down if you are feeling a bit like this is going by a little bit fast. Just curious to know. Okay, cool. Because we still got plenty more to do, but I like, it seems like we're all mostly on the same page. And even if we're not, don't worry, we will get there eventually. Okay, everyone. So I think that we are all in need of a stretch. So let us stand up, and I want everyone to turn their cameras on. And we have been going for over half an hour already. So let us give our bodies a break. And let's start by just gently swinging our arms nice and loose. And just let your body relax like you're a rag doll or something.
Guys,
then,
please turn on your cameras. Let's see your lovely faces.
And then what we're going to do is we're going to twist from our waist. So at first, only a little bit. And then as our bodies get looser, we're going to click a little bit, but we're also going to be able to turn further. So we turn, and then it's almost like, yeah, we're rotating. And can you feel yourself able to go further?
Oh, yes.
Your body like loosens up. Okay, then let us do some small circles. So small circles with your arms, and then bigger circles, and then eventually into quite big circles where you're just releasing kind of your shoulders. All right, and then let's do a like a meridian crossing thing. So take your right hand and put it on your nose, and take your left hand and put it on your right ear. I haven't done this for a while. I'm going to confuse some of you. Okay, now the point is for this hand to go to your nose and this hand to go to the opposite ear. See if you can do that. And then see if you can bring this hand back and then this one to go across like this. See if you can
I think I'm very good at this one.
See if you can switch your hand. It requires your brain to kind of switch over from side to side. That's apparently quite a good one for telling your left brain to talk to your right side or something like that. Then let's have a quick sip of water. Hopefully you have some water nearby. And let us do let us do 16 knee taps. So what we're going to do is you go 1, 2, 3, and so on. But we're going to do it the faster rhythm. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. Training session over.
Yay. Well done, guys.
And as silly as it may seem, it really does help your brain unwind. And so I think that it's well worth an investment in our time. So here's your challenge or your quiz question for today. How many days are there in 4 years? Put your answer in the chat. Juliet, my arms. Couple of different answers. 0.6, 0.60.
Annie's mom walked into her room and gave her a look. She's probably
Is
like,
it?
are you supposed to be exercising or doing math?
They're like, no, the teacher told me. Okay, I see some of you have got the sneakiness. Some of you have missed it. So how many days? So you're right to say 4 times 365, but the thing is, every 4 years, there's a leap year. And so it's 365 times 4. And then every 4 years, it's the 29th of February. We add an extra day basically on the 29th of February. And so the answer is in fact 1461. So I see, congratulations. Oh, you didn't know that. Yep. Watch out. When is the next leap? I know it wasn't a leap year this year. I don't think I would have noticed it. But yeah, every 4 years, you'll notice on the 29th of Feb, there's an extra day in the calendar. But bananas there. It's got to do with the orbit or the Earth's orbit around the sun, as far as I remember.
Yeah, you learn
Next
something
year.
new every day.
Yeah, next 2024. So it's next year. Fantastic.
Ah.
So I'll watch out for that. Okay, everyone, let's keep rolling. We've been doing so nicely. So what is the length of side A in this question? So using the same idea, what is the length of side A in this question? So I'm going to follow the advice from before. I label this O, this H, and this A. So I want to find what A is. So I need to involve this side. And I also need to involve this side, I think. So for me, what involves O and H? It's going to be sine, because I've got to use this side and this side. Maybe ticking is a helpful thing to do. So you tick the 2 sides that you know are involved, and I'm going to get the sine of 64 is equal to O. So, or in this case, it's little a, which is a bit confusing, I guess, and over 10.8. And then I know 10.8 times the sine of 64 is A. And so what do we get for that? What's the final answer going to be? 9.70. And so the correct answer should be C. And I see lots of students have got that in the chat. Brighton, Bianca, Chumaxi, Pinksy. Yeah. Okay. But if you are confused, that's not a problem, as long as you understand kind of each time you're looking out for a couple of things. Though I liked how I ticked the two sides that were involved. I thought that was a good idea to help remember. Yeah. Okay. Now, I think you guys have got finding unknown sides down. So you've got finding unknown sides down. But now sometimes in trigonometry, we have to find unknown angles. So if we're finding unknown angles, it's slightly different. So let's have a look here. What you notice in this question, or maybe someone can come online and tell me, what do you notice is different about this question, like in terms of what you're given and what they're asking for? Would anybody be willing to come online and share kind of how they see this being different? So Malaikaya has said something. I think that's interesting. Mambali and Zanele, what do you think?
They didn't give us an angle.
Aha, they didn't give us an angle. The angle is unknown, but what did they give us? See for you. What do you think, Mbali and Zanele? What did they give us?
They gave us hypotenuse side and
So you gave us
opposite.
10? Yep. Yep. And I liked what you did there. You went and looked to try and classify them, and you said this is H and this is O.
Yeah.
And they only gave us two sides. Now I want to ask you, Mbali and Zanele, what trig ratio do you think is involved in solving this question? Any ideas?
It's sine.
Sine. Absolutely perfect. So we say the sine of x is equal to over h, or 7 over 10. And what I'm going to suggest, everyone, is if you feel unsure, I would write this acronym down every time you do a question, or write it once in your test and keep referring back to it. Because we saw there how easy it was to know if it's O and if it's H, it's going to be sine over here. Now we're not done. There's no answer, which is 7 over 10. But that makes sense because we're not looking for sides. We're looking for an angle. Who can tell me, how do I figure out what the angle is? Let's go to Bomoklaka. Can you hear me?
Hi, sir.
Hey, what can you give me a tip? How is this different to what we were doing before?
Before, sir, we were looking for the side that we had the angle and we were looking for the side. Now here we do have the angles, but now we are looking for the, no, we do have the sides and we are looking for the angle now.
Exactly. So tell me, I'm going to use my calculator. What do I need to do to tell the calculator to give me an angle and not a length, or not a side, or a ratio of sides?
You have to take the sine to the other side and it becomes sine -1. Then you substitute fraction.
All right. Now, just to point out, when we say sine -1, what they really mean is the inverse side. It's not -1 like in exponents. What they mean is on your calculator, you go shift sine, and then you type 7 over 10. You basically tell the calculator, look, I'm giving you a ratio of sides. And when you click shift sine, you're telling it, give me the angle that was there in the beginning. So it's really important that you click shift, and then when you hit the sine button, you'll notice that it's got the sign that looks like a -1, but what it's really saying is go the other direction, or the inverse. Okay, what is the answer for this one? If you put that in your calculator, is the answer going to be A, B, C, or D? I've got to do this too. So I'm going to go shift sine, and then I'm going to type with a calculator 7 over 10. Okay, and I've got my answer. It is 44.4. And that means that this B is the answer. And just to show you what it's telling us, that's saying that this angle over here is 44.4. And so we're using trigonometry to work out an unknown angle, and we use what's called the inverse sine function, and it goes from a ratio of sides to an angle. I love what I'm seeing in the chat. Looks like everyone's on board. Let's do another one, just to practice our newfound skills. What is the size of angle X in this particular thing? And I know this is getting a little bit, the printing is a little bit funny, but there's an X up here. What is the size of angle X? Is it going to be A, B, C, or D? So it seems like labeling is always a good idea. So that's O, and that's A, and that's A. So now, I'm going to use the ticking method. I'm going to tick this one, and I'm going to tick that one, because it feels like that's where the action is. And now I've got to ask myself, if I can't remember, this could help me look it up. Where's O over A? It feels like it's this part here. So now what I'm going to do, I'm going to write the tan of X is equal to 10 over 8. Now that's not the answer, but it's getting me closer to the answer. What is the final answer going to be? So I go shift tan, and then I'm going to get 10 over 8. And I get 51.34, which is going to be C over there. Okay, so when we're given right angle triangles, we can also find the missing angle. Yeah, Afika, let's go to you. What's your question? Afika, can you hear me? Hello. I think the sound isn't great. Can you hear me?
I think the network is bad in the States.
Okay, I think we'll go to another question, and then I'll try and answer the question while everyone's busy. Last question of the day. What is the size of angle X? What is the size of angle X in this question? Hmm. Hmm. Yeah. Sorry. Okay. What is the size of angle X? I guess that's O. That's H. And that is A.
Is it just me, or can you still hear the sound?
I can still hear the sound too. I don't know what's going on. There must be some sort of audio glitch. Let me hit mute all again.
Okay.
Okay, sorry guys, we're having a bit of audio thing, I think. But I'm going to keep it on like that for now. All right, last question. So we want to find X. I think A and H are involved. So soccer, and A and H involve cos. So we write down the cos of X is equal to 5/8, which then means that inverse cos of 5/8 should give us our angle. So inverse cos 5, or sometimes they say arc cos, but that sounds a bit fancy. 51.31, which is A. So 51.31, and that is A. All right, well done, everyone. You've completed your first lesson on trigonometry fundamentals. The whole idea today was just to show you how with trigonometry, sometimes we solve for lengths or sides, and sometimes we solve for angles. And so those are important skills. The thing about today is we stayed in quadrant 1 with O, A, and H. In the next lesson, we're going to talk about how is it possible for the reference angle to not just be 30 or 40 or 50, or, you know, the angles in this case were all acute angles. They were less than 90. It's possible for trig functions to have angles greater than that, but that's a little bit weird when you think about a triangle. And so we'll start to talk about that in the next lesson. But yeah, you did very well today. And then Lebo, could you put the poll out to the students so that they can vote? We really appreciate, yes. So in the next lesson, we're going to sort of start to touch on reduction formula. And, you know, we'll start to talk about how can something like the sine of 220 have a value if the angle is the input. That's a little bit weird when you think about it, because the most amount that you're allowed in a triangle is 180 normally. So how do we explain the fact that the sine of 220 has a value? And that's where the Cartesian plane comes in. It's quite helpful in extending the definition. But yeah, I think it's good to do just a little bit every time so that your brain can click save as, and then each lesson will build on top of it. So Juliet, can I suggest that you have a look at the people who are feeling very confused about the reduction formula, who are writing tests this week? I'll just show you very quickly where on the Watobe website. Let's see if I can go to, what am I showing? Here we go, Watobe. So if you really need some trig reduction help and you cannot wait until later in this course, then if you go to grade 11 and you go to, where was it? Exam revision. So exam revision from last year, you will see that there is some general trig that you can talk about here, general trig basics and general stepping up. And you can also go back to trigonometry general from all the way back from last year. If you click on trigonometry general, there are some lessons on reduction formula that you can have a look at. So if you're absolutely stuck, then that could possibly be a way to help.